All right, great. So we've got a way to actually get this pricing information pretty easily. However, our code is getting a little bit cluttered with these get price and get conversion rate. You'd think that these are functions that would be reused pretty often anyways for anybody looking to work with Chainlink price feeds. So is there an easier way for us to work with this pricing information? Maybe doing some math like this is pretty common, and we'd want other contracts to be able to import this conversion functionality. And a way that we can do that is actually creating something called a library. There's a site out there called Solidity by Example, which has great examples of using libraries and what they work with. Libraries are similar to contracts, but you can't declare any state variables and you can't send ether. A library is embedded into the contract if all library functions are internal. Otherwise, the library must be deployed and then linked before the contract is deployed. That's a little bit confusing. Don't worry too much about that right now. Using libraries can actually add functionality to different values. And what do I mean by that? Well, I mean, we can have our get conversion rate function be a function of any value of type uint256. Means we could take this get conversion rate and do something like message.value.getConversion_rate. So we can create our own custom function with any type. So we could work with get conversion rate as if message.value was a class or an object or a contract that we actually created. To do this, let's go back to our files, create a new one called price converter.sol. And this is going to be a library, a price converter library. So how do we create a library? And what is a library? Well, a library is going to be very similar to a contract. We're going to start, of course, with SPDX license identifier. We're going to do pragma solidity, and we'll give it a version of 0.8.18, the little caret. And instead of typing contract, we're actually going to type library for the name of the library. And we're going to call this library price converter. So libraries can't have any state variables, and all the functions have to be marked internal. So what we're going to do is we're going to go back to fundme.sol. I'll zoom out a little bit. We're going to grab get price, get conversion rate, and get version, delete them. Well, I hit copy first, go back to price converter, paste them in here, and work with them in here. Of course, we're going to need the aggregator v3 interface. So we're going to go back to our fundme. We're going to copy this named import from aggregator v3 interface, paste it in at the top here, hit Command S, and we're going to go ahead and compile this successfully. Fundme is no longer going to compile, but we're going to fix that in a little bit. Now, the first thing that we're going to need to do in here is make these all internal. So we're going to say internal like this. We're going to do internal get conversion rate and internal get version. Now that we have our price converter library, we can actually import it back in our fundme and attach it to a uint256. And let's actually delete this aggregator v3 interface line for now. And we'll do import price converter from /price converter.sol. And now to attach the functions in our price converter library to all uint256s, we'll say using price converter for uint256. Of course, if we compile our fundme, we're going to get an issue because it doesn't really know what get conversion rate is. So for now, let's actually just comment out this line. I'm going to remove these comments up here as well. So what we can do now, though, is we can do message.value.getConversion_rate. Get conversion rate. And in your library, whenever you're working with a library, the first input variable for a library is going to be the type that you're using with the library. So message.value is of type uint256. So this gets passed inside of getConversionRate as the first variable into uint256 eth_amount, even though we don't pass any variables inside of these parentheses here. For get price and get version, we don't really care to have an input parameter at all. So it'll pass it in, but not do anything. So now, instead of require get conversion rate of message.value, we can actually do, let's uncomment this line now, and let's delete this line. We can actually do message.value.getConversionRate. And now, if we compile this, this is going to compile successfully. This works because we're attaching the price converter library to all uint256s. So now all uint256s have access to this get conversion rate function. And since message.value is a uint256, it can call .getConversionRate and it'll pass itself, so that message.value, as the first input parameter to the function here. If we wanted another variable in here, like uint256 something else, that would be the first parameter inside these parentheses. So maybe like 123 or something, right? This 123 would be the something else, but message.value would still be the initial parameter, which in this example would be eth_amount. So let's go ahead and undo that and undo that. But all right, great. We've moved a lot of the math into our own library. Congratulations. Nice work.